Hello, everyone, and welcome to another episode of the Day 1 to Deep Tech podcast series, where we explore the stories behind today's most exciting technologies through conversations with the people building them. Today's topic is physical AI. Artificial intelligence has already transformed the digital world. It recommends movies, answers questions, translates languages, and helps businesses analyze data. But what happens when artificial intelligence moves beyond screens and begins interacting with the real world? What happens when robots can see, understand, move, learn, and make decisions inside factories, hospitals, farms, warehouses, and even our homes? That's where physical AI begins. To help us understand this rapidly growing field, we're joined by the founder of a successful physical AI startup. Thank you for joining us today.
Thank you for inviting me. I'm excited because physical AI is one of those technologies that people encounter every day without always realizing it. When a warehouse robot transports packages, when a self driving agricultural vehicle navigates a field, when a robotic arm identifies products using cameras, when a drone inspects power lines, when a surgical robot assists doctors, physical AI is quietly making those systems intelligent.
Before we talk about the technology, let's start with your story. Did you always know you wanted to build intelligent robots?
Not at all. When I was in engineering college, I loved programming. I also enjoyed electronics and robotics competitions, but I treated them as completely separate subjects. Artificial intelligence belonged to computer science, robotics belonged to mechanical engineering, embedded systems belonged to electronics. I didn't realize that one day all of these disciplines would come together into something called physical AI. Like many students, I had no idea this would become my career.
So, how did everything change?
My first job involved developing software for industrial robots. Initially, I believed robots simply followed pre programmed instructions. If you wrote the correct program, the robot would perform the task perfectly every time. But during one customer deployment, something unexpected happened. Boxes arrived on a conveyor belt in slightly different positions than expected. The robot kept missing them. The software wasn't broken. The environment had changed. That experience taught me something fundamental. Traditional automation assumes the world remains predictable. Physical AI allows machines to adapt when the world changes. That realization completely changed my career.
That's fascinating. For someone hearing this term for the first time, how would you explain physical AI?
I like using a simple analogy. Imagine a person walking into a room. First, they observe their surroundings, then they recognize objects, they understand what's happening, they decide what to do. Finally, they move and interact with the environment. Physical AI follows a similar process. An intelligent machine uses sensors, cameras, microphones, LiDAR, or other devices to perceive the world. Artificial intelligence interprets that information. The system decides what action to take. Then motors, robotic arms, wheels, drones, or other actuators perform that action. Unlike traditional AI, which mainly processes digital information, physical AI connects intelligence directly to the physical world.
So, it's much more than simply adding AI to a robot.
Exactly. Physical AI combines several technologies into one intelligent system. Robotics provides movement, computer vision provides sight, sensor fusion combines information from multiple sensors. Machine learning helps recognize patterns. Reinforcement learning enables better decision making through experience. Embedded AI allows intelligence to run directly on devices. Cloud and edge computing provide additional processing power. All these technologies work together so machines can understand and interact with their environment.
Many students listening today may be wondering, why am I learning all these different subjects? How would you answer that?
Because no intelligent machine relies on a single technology. Imagine a warehouse robot. Its cameras detect shelves, its LiDAR measures distance, its sensors monitor movement, computer vision recognizes packages, machine learning identifies patterns, sensor fusion combines information from multiple sources, reinforcement learning helps improve navigation, embedded AI performs real time processing, edge computing enables quick decisions, cloud platforms coordinate hundreds of robots. Every subject contributes one essential capability. When students learn these topics individually, they sometimes wonder why. Physical AI shows how they all work together.
Where did your career go after that first deployment?
I joined a company developing autonomous mobile robots for logistics. Every project introduced a new challenge. One week, we were improving computer vision. The next week, we optimized sensor fusion. Then we experimented with reinforcement learning inside simulation environments. Later, we deployed embedded AI models directly onto robots. Every project showed me that intelligent machines aren't created by one algorithm. They're built by combining perception, decision making, control, and continuous learning. Eventually, I realized I wanted to build my own company focused entirely on physical AI.
Many people confuse physical AI with traditional artificial intelligence. What's the biggest difference?
Traditional AI usually works with digital information. It recommends products, answers questions, processes documents, generates images. Physical AI goes one step further. It must understand the physical environment and act safely within it. Imagine asking an AI chatbot to answer a question. If it's slightly incorrect, you simply ask another question. Now imagine a warehouse robot carrying a heavy package. If it misunderstands its surroundings, it could damage equipment or injure someone. Physical AI operates where every decision has real world consequences. That makes perception, safety, reliability, and real time decision making incredibly important.
Where are we already seeing physical AI today?
Almost everywhere. Manufacturing robots assemble products. Autonomous mobile robots move inventory inside warehouses. Agricultural robots monitor crop health. Healthcare robots assist surgeons. Drones inspect bridges and power lines. Construction robots perform repetitive tasks. Autonomous mining vehicles operate in hazardous environments. Smart service robots assist customers. Even household robotic vacuum cleaners use many physical AI principles. The field is expanding rapidly because industries increasingly need intelligent machines that can adapt to changing environments.
Before we conclude today's opening segment, I'd like to ask one final question. If you could go back to your college days, what's one misconception you'd immediately correct?
I'd tell myself this: don't study artificial intelligence, robotics, electronics, and software as separate subjects. Learn how they connect. That's the biggest lesson. The future belongs to engineers who understand systems rather than isolated technologies. Physical AI isn't one discipline, it's the convergence of many disciplines working together to solve real world problems.
That's a wonderful way to begin today's conversation. We've learned that physical AI isn't simply about building smarter robots. It's about creating intelligent systems that perceive, understand, decide, and interact safely with the physical world. In the next segment, we'll explore what working in physical AI is really like. We'll discuss physical AI fundamentals, robotics, computer vision, sensor fusion, machine learning, reinforcement learning, embedded AI, human robot interaction, digital twins, industrial automation, safety, and ethics, and discover what textbooks rarely tell you about building intelligent machines. Stay with us.